Hello and welcome to today's quiz. Pen's ready, get yourself a paper. As always, just draw your little triangle and circle where you think it is, or if the question requires you to do some working, then do that. Pause the video when you need it. Question 1. So a cat sits on the mat, it's a 4 kg cat. Which force diagram has the correct value for the force of gravity? So pause the video if you need some more time, and we'll move on to question 2. Question 2, the cat's sitting on the sloped roof. I've given you a force diagram. Out of the 3 vector addition diagrams, and they're all the same in terms of the forces there, but which of these diagrams has the 30 degrees placed in the right place? You see the 30 degrees is on the slope roof. Which of these the vector addition diagrams has that 30 degrees transferred to the right place in the vector addition diagram? Pause the video to think about that one. And we're moving on to question 3. A car starts from rest and speeds up. During this acceleration, the car travels 100 meters in 10 seconds. What is its final speed? So you definitely will need to pause the video to work this out. I have copied and pasted I've copied and pasted a bunch of formula from the year 12 formula sheet, which might help you. So pause the video to work that answer out. Right, we're moving on to question 4. Rearrange this equation to find D. So you'll definitely need to pause to work your way through that. So you've done your working. Let's now go through the answers to question 1. So the common mistake here is that people forget that this is the mass, 4 kg is the mass, and sometimes they put that in as the force of gravity. Not the case, okay? This is in newtons. This one here is also a common mistake. People just forget, and the force of gravity is not 9.8. The gravitational field strength is 9.8 newtons for every kg. Okay, so don't confuse that with putting it down here. And because it's 9.8 newtons for every kg, and the cat has 4 kgs, if you times those together, you get 39.2. The cat's sitting on the slope roof. Where does the 30 degrees go? This is actually a common bit of a tough problem for people. You should be able to get it down to 2. So for example, the 90 degrees, I always find the 90 degrees, and it's pretty obvious where the 90 degrees is here. It's here. So this one, the 30 degrees doesn't go here because that's 90 degrees. If you're still worried about where the 90 degrees is, look back at this diagram here. The normal force is always parallel to the surface. It's almost 90 degrees to the surface. There's my 90 degrees. And the friction force always runs along the surface. So there's always 90 degrees between these two, the normal force and the friction. So here's the normal force and the friction. Between them is the 90 degrees. So I found the 90 degrees. That's definitely not where the 30 degrees is. So then my 30 degrees, that's the answer, but we'll talk about how it got there. It could be there or it could be here. You can do it mathematically. And you can do triangles. You can say, well, this is a 30 degrees here. This is 60 degrees here, which means that this angle in here is 60 degrees, which means if this is 90 here and I bring this down to here, that's kind of the triangle I've got. This must be 30 in here as well. Because this is 90 and then this must be 60. That's one way of doing it. I mean, that's tough though to get there. The cheats way I use, this is the real cheaty way. I say, what if this was extreme? What if this was really extremely not a very big angle? Right? And when I draw my normal force, it's hardly on an angle at all. My gravity force is straight down and I've got a tiny little friction force up here. When I go to draw my vector addition diagram, this one's hardly on an angle, and then this one goes up like that. This angle, which is, let's say I'll just make it up, 4 degrees or something. Where's my tiny little angle on my diagram? Well, that's quite big, that's quite big. The only tiny little angle I've got is this one down here. That's the cheats way I use. I redraw this diagram and say, what happens if I'd had a really small angle? And that helps me to find really quickly where the angle should be. So that's, yeah, a tough problem that comes up, and people seem to forget that. But obviously with everything, through practice, you get better. Okay, a car starts from rest and speeds up. Because it speeds up, we're going to use the uniform acceleration model. We are not going to use the constant speed model. And the common mistake is when people see problems and they say, oh, I've got a distance here, I've got a time here. What formula have I got? Oh, there's a distance and there's a time. This formula is for constant speed. You can't use it for acceleration. It is for constant speed. The rest of these 5 are your uniform acceleration formulas. So this is the reason I put this question in, is because I knew a bunch of people are going to get that as their answer. When you use an actual uniform acceleration formula, and one you can use is because it starts from rest and its initial velocity is 0, you can use this one here and rearrange this formula to find your final velocity. It ends up being 20 meters a second. And rearrange to find d. I want to make d by itself. What I'm going to do first is I'm going to get rid of vi squared. So vf squared minus vi squared equals 2ad. And then I need to get rid of the 2a at the time, so I'm going to divide by 2a, divide by 2a, vf squared minus vi squared, all over 2a equals d. Great, give yourself 3 marks if you got that one.